What I was doing there is I was showing how you can use a rollover to do translation. So these are my programs, and what I'm showing here is that if you can put translation on a rollover, and the student just sticks their cursor on that and they can get the translation. And then this right here is a graphing exercise, Flash to simulate, to show the students how to do. So I'm modeling what they're supposed to do. And of course this isn't fast speed, so it's not this fast when I'm doing it. And I talk during the lessons. I'll show you that in a minute. So here you're seeing students are able to watch, what exactly they're supposed to do.
Let's do an example of how to locate the epicenter for an earthquake that takes place in the United States. This is a seismograph from Salt Lake City. Here's where the P wave arrived. It was 1 minute. Here's where the S wave arrived. That was at 4 minutes. So let's write that down. The arrival time for the P wave was 1 minute. The arrival time for the S wave was 4 minutes. So then the difference in arrival time for the P and the S wave is equal to 4 minutes minus 1 minute, which is equal to 3 minutes. Okay, so we know the difference in the arrival time. That's all we need to know to come to the P and the S wave chart here and to find out how far away the epicenter was. So I measure out 3 minutes over here on the scale for time. See that? Now I slide along the P and the S wave chart until I find exactly where 3 minutes fits. Right there. You see that? Now I drop a line straight down that little dotted line, and I found it. I put a little box around it. That's 1,800 kilometers. Therefore, we now know the city is 1,800 kilometers away from the epicenter. So I go to my map right here. Now if you look right up here at the top of the map, there's a scale, and I'm going to measure out 1,800 kilometers. You see that? It's right there on the scale. Okay, that measures 1,800 kilometers. Now I'm going to take that line and I'm going to bring it down here to where Salt Lake City is. Okay, just done that. See that line? That's 1,800 kilometers. I've labeled it. Now if I were to draw a circle around Salt Lake City that's exactly 1,800 kilometers in radius, like I've just done there, then anywhere on that circle we could have had the earthquake. We don't know where, but anywhere on that circle we could have had it. Okay, once again, I measure out 800 kilometers up here on the scale. I measure that same distance from Houston. There's 800 kilometers. I draw the circle, and as you can see, this circle intersects in 2 spots. Now we've narrowed down how many places the earthquake could be to one of these 2 spots. Okay, now remember, when you guys do it, you're not doing it on the computer. You're going to be using a compass, and you're going to measure out the distance with the compass. You put 1 point at 0, you put 1 point at the distance. In this case, it would be 1,300 kilometers. And then you put 1 spot on the city, and you are able to draw your circle. So we measure 1,300 kilometers from Savannah. We draw our circle. And as you can see, all 3 of these circles now intersect in 1 spot. Okay, so I put a box around this spot. Now, you haven't finished until you've actually put an X where the epicenter is. So here's my X. Okay, and now I'm finished. I have my 3 circles. They all intersect in a single spot. I've marked that with an X. That's where the epicenter is. That is the only place in the United States that is the correct distance from Salt Lake City, the correct distance from Savannah, and the correct distance from Houston.
Okay, so I just showed you that so you can get a feeling for what it's like. But what you're seeing here is that the student is actually able to do the assignments And then you basically can plot the point in the graph, and the computer immediately tells you if you got it right or wrong. So what you're seeing is that in addition to being able to do a little short video like that, you're also able to have it be interactive, where the student can answer questions and find out if it's right or wrong. Now, many people have heard various people say that you remember 80% of what you do. That fact is unproven and is basically false. What we do know is that practice has a very real and powerful impact on learning music and video games, but much less of an impact on other subjects. And I would say that the reason is that it's because of instant feedback. When you play an instrument, your ear gives you instant feedback, and likewise, when you play a video game, you are getting instant feedback. We also know that formative assessment is the one form of assessment that has been proven to help students learn, and to me, instant feedback is formative assessment. So in my programs, I incorporate instant feedback with formative assessments. If a student gets a question right, we move on. If they get it wrong, they learn instantly that it's wrong. Plus, I give them a small explanation of what they should be focusing on, and then I have them do the question again to confirm that they now understand what to do. Students learn by doing. We know that in order for practice to induce learning-dependent brain changes, it must be meaningful, motivating, skillful, challenging, and rewarding. The point is, you cannot provide meaningless rote exercise and expect results. You have to have formative assessments, instant feedback, capitalize on teachable moments, increase the rigor, and maximize the accountability. Then each year, the results are tied into a feedback loop to look at the results and make appropriate adjustments. I've been doing this since 2006. Now please note, the correlation between practice and mastery is not 100%. I also have seen the same thing. If you have a level 4 reader, they are reading at least one grade level above their grade, they will score about 10% higher than I would predict based solely on their use of my program. A level 2 or 3 reader, those who are at or slightly below grade level, will score where I would predict based solely on the results with my program. And a level 1 reader is going to score about 10% or below what I would expect. An English language learner will score as much as 30% below. This is also true of some special ed students, but not all. Just those with a learning disability. However, ADHD kids and oppositional defiant do better with this program. It's easier for them to focus and less opportunity for extraneous issues. Without a doubt, the skills and knowledge base of the student will impact the results. However, this program has been used in the inner city Brooklyn school system, where we have about 25% of our population of special education. We have about 10% of the students in the general education population are English language learners, and overall, most of our students are reading below grade level, some by more than a year. Now, the strongest evidence of improved learning gains comes from short cycle, over seconds or minutes within a single lesson, formative assessment, and medium to long-term assessment where assessment is used to change the teacher's regular classroom practice. This comes from a study by William and Dillon, 2006. Formative assessment, getting the focus right. Now, to get a close correlation, you need high-quality practice with instant feedback. This is one of the big advantages of this program. The instant the student submits their response, they get feedback. I view this time as my best teachable moment. So with the feedback that the student has not understood, I give a short explanation of the key concept involved. I also will then include a repeat of the same question. This way, the student knows they do not understand. Here is the explanation, and you're going to have to answer this question again. However, the second time they answer, it is not graded. Games and music both have a formative assessment built in. If you're playing a game, winning and losing gives you instant feedback. If you are playing an instrument, you can hear the sound. That's instant feedback. Generally speaking, education does not see a clear correlation between practice and mastery. However, with this program, practice is much more like that of a game or a musical instrument. As a result, I have a very good correlation between the assignments and the ultimate score on the Regents. Formative assessment properly implemented is a powerful means to improve student learning. This is more efficient. According to an article by Jennifer Salopek in Training and Development magazine, e-learning courses progress up to 50% faster than traditional courses. This is partly because the individualized approach allows learners to skip material they already know and understand and move on to the issues that they need training on. I have seen this in my own classes. Every year I am able to cover significantly more material quicker and with more rigor than other or science teachers. Self-paced. Students miss classes for many reasons. Sometimes they are transferred in partway through the semester, sometimes they are sick, sometimes they go on field trips, school trips. A second critical reason for a self-paced course is for kids who have failed the Regents and are studying to take it again. I can look at their tests and determine where they need the most help. Then I can give them these lessons. I can actually prescribe individualized courses for each student depending on the need. And of course, students can do these from any location at any time because they're on the internet. And it gives me greater accountability. I can measure exactly how much each topic an individual student has done. This allows me to see the need and allows me to evaluate how effective these lessons are. I can also determine prior to the Regents who will score lower than their score indicates and can therefore take action prior to the exam. Also, I've learned every year where the shortcomings are and have taken steps to correct that. Last year I completely overhauled my lab practical lessons. This year my class average on the lab practical was 14 out of 16. I feel at this point the law of diminishing returns suggests that I should focus on other areas. This year I worked on overhauling my meteorology lessons, and this was the topic my students did best on. A 9-year survey of the research literature and training published by Fletcher and Tobias in Training and Retraining, commissioned by the American Psychological Society and published in 2000, concluded that learners learn more using computer-based instruction than they do with conventional ways of teaching, as measured by higher post-treatment test scores. Specific studies from Fletcher in 1999 and Kulik in 1994, Willett, Yamashita, and Anderson in 1983 all confirm that learners learn more using computer-based instruction than they do through traditional classroom methods. Brandon Hall, 2001, notes that the learning most suited to e-learning conversion includes information and knowledge and processes and procedures. The report noted that learning gains have been found in learners' attitudes toward the format and training in general, learners' scores on tests, the number of learners who achieve mastery level, the learner's ability to apply new knowledge or processes on the job, and the long-term retention of information. Chunking. Various studies show that it is better to have short daily sessions of study rather than cramming for several hours. This is particularly true for some SPED students. In addition, rather than teaching several concepts for 15 minutes followed by practice, it is better to teach one concept for 1 minute followed by practice. These assignments do that. The entire course is broken into 120 assignments designed to be done over the course of the year, 30 per marking period. Also, questions are given as soon as the concept is taught. I try to maximize the concept of chunking. I teach just enough so the student has the tools to solve a problem, and then I give them several problems on that concept. In addition, the vast majority of assignments have about 5 review questions from previous assignments so that the understanding can move into the long-term memory. John Henry, the steel driving man. This is a story about a man who raced a steam-powered steel drive and won. His job was to use a drill to make holes in the rock for explosives. Someone invented a steam-powered machine to do the same thing. He raced the machine and won, but then died when his heart gave out. To me, this illustrates the power of the computer. We can design a lesson that will perform as well as the most outstanding teacher in the entire country. It may be that a teacher somewhere could beat the computer, but they would certainly be dead by the end of the year. It is as though I am teaching each student individually, even if I have 100 or more students.